um, a YouTube video. I'm posting the session over here so I can see you all. I'm, I'm, I will try to always have the session to be on YouTube in case students don't show up. As I mentioned, um, one day I already discussed the difference between a virtual course and an online course. You sign up for an online course, however, um, the school wants me to do it just like almost a virtual and have sessions for students if they want to participate, if they have a question so I can clarify, and other information. So, see, I can see there. So, yes, bright and now really dark. So, not now, it's really dark. That was good. So now it's there. So today we are going to talk about chapter 4. The chapter is about operating system security. Now, and I will explain a number of things. Then we will go ahead and talk about chapter or project 4. This is the key important thing that I'm making is that I'm explaining how you can do the project, why you're doing the project, and so on. So just let me someone send me a message. So this week I want to mention that this week. Oh, cat! I have one. It's white, all white. I have like gray one. So yeah. Okay. Tara, you're live now. You're here. So this module or module one going to be ended this week. You have 4 projects that almost all students need to have to set it up and or to submit it. If someone did not submit it by the 20th, that means 21st is here and you did not submit project 1, 2, 3, or 4, you will get a 0 on it. And next week we have module 2. We will have kind of an upper level kind of courses to be much more um, and um, and that's why I'm covering it one by one. Each module have 4 chapters or 4 project, and I'm taking it one by one. I'm not rushing anyone to do something. So let's go ahead and talk about the chapter. Simple chapter, 25 slides, easy, that not that complicated. We will finish in like 1 minute. Based on my explanation, it will be like 2 hours. So the operating system environment. Before we start, most of you now know that there's a computer, a device going to be divided into a hardware and software. It's not only the security that I need to care about the software or the hardware itself because someone can steal it or damage it, but now we have information on it. I want to secure the information on it. I want to secure the data. And how I can secure it by making sure everything is addressed. There's impossible. There's no 100% security. I've already mentioned that there's no 100% security. The only way that if you want to have 100% security, disconnect your computer from an online. Don't connect it. Don't put a CD in it. Don't put a thumb drive in it. Or you need to accept there's risks, there's vulnerabilities, there's a lot of things, and you need to accept that. So when it comes to the operating system, now application going to depend on the operating system so it can work. Um, There's no computer hardware. There's no computer without software, without an operating system. An operating system is a must to be in a computer. In fact, there's a small utility in the operating system called the kernel. The kernel is the place where it will take the binary into zeros and ones, and that's how it's been implemented into hardware, or the hardware component of the computer. So now we are going to talk about the operating system environment as total. The objectives and the goals. If you if you go and read the goals, you can link between the goals and discussions, because I took the goals and put it as my discussion because that's my goal. Now you see me looking at that side and over here. This is where I put the videos where I can see you. Over here is your chat, and this is what you see, the one in the middle. So technically I have 3 screens. Now, what is operating system? An operating system is a manager of the hardware and the software resources on a computer. It controls resources usage and access, and provides a mean for the user to interact with the computing system via an input and output devices, or via a GUI display on a monitor. GUI stands for the graphical user interface. GUI, graphical user interface. The user will put their commands through input devices like mouses, and don't ask me why I have 2, or other type of devices, and the operating system will take it and implement it based on the application it's using. The operating system out of a box is not secured without further configuration. You must develop a secure baseline for all the computers in your organization. Stop over here. When we talk about computer in small office or home office, it's totally different than computing into an organization where you have a centralized network, you have servers connected to the network, and so on. It's totally different. But the computer cannot be, you open the box and send it to this employee, he's ready to go with the box. No. You need to configure Windows to have a number of baseline, and baseline minimum, that means the minimum that you need to achieve. And we will talk today about the baseline. The operating system is where your application live and access the network if required. Requirements such as a password are often ignored time and time again. The operating system connects to the network, and there has the ability to access the web using the internet. Common operating system, talking about, and don't care about the list that you have, talking about Windows in 2018. In 2018, Windows did control around 90% of the 383 million PCs sold, I think, or in the market, 90% of the market in the 2018. And Macintosh, actually, Mac operating system with Linux did have the other, 10% divided between them. Let me say 80, and then you have a couple for Macintosh, because we have a large population for Macintosh. Then we have Unix operating system. It's a type of an operating system, type of I think, Linux. I'll give you an idea, but I will bring an image of it. Just give me 1 minute. Let me put it over here. It's Oracle. That's what they talk. A type of Linux. Kind of type of Linux. Okay. Now, if we talk about Linux, there's a lot of flavors. You have Ubuntu. You have Linux Mint. You have Kali Linux. There's a lot. Debian Linux, Fedora Linux, a lot of Linux. Now, almost all versions of Linux are almost free of charge because who created it meant to have it for free. Windows is not for free. Macintosh, yes, technically free, but you must purchase an Apple device, and that's why you need to have. Um, then you can use the Macintosh. Now, Windows is one of the main operating systems that in usage right this moment. Currently, we have Windows 10. Both Linux and Macintosh are based on a Unix code or Unix kernel. So that's why you can see there's a lot of similarities between them. Not a, some similarities. I don't want to say a lot. Some similarities between them. The structure of the drivers and the directories and how the root controlling the entire thing is the same. But in Linux, we have a lot of names for it, flavors for it. So operating system threads. Many of operating system threads arrive via the information system's network infrastructure. Viruses are malicious code developed to reside and run silently on a user operating system. They are developed to pass from computer to computer via email or some way. Let me stop over here. In fact, if we switch it, malicious code, and we talk about, I don't want to mention only viruses because malicious code or malicious malware, let me call it malware because currently we call it malware because it's called malicious software. And malicious software is not only viruses, it's other things like worms, like Trojan horses, like spywares, like adwares, a lot. I'm talking about a lot. And each one have a different aspect of it. For example, viruses, why they call it the word virus? Because it need to have a host. What the meaning of host? That means it need to have place to live. And a virus, just like human virus or animal virus, need to have a host to live in it. So a place where it can live. And viruses, technically, is the malicious code of the virus will be implemented inside files and executable files also, and can jump from one place to another. Now the virus need to have a user input. That's one of the things. Need to have a user action to activate it or to do something and make it to work. Worms are totally different. Worm will replicate itself from one computer to another, one drive to another, and without the input of the user. So each one will have a different way to spread, and each one have a different way to create itself. Let's talk about a number of viruses. We have the boot sector virus, which is a type of an attack which occurs when the first sector is loaded into a memory when the computer is started. That's the boot. This is the first thing will come is to load through the boot process. We are loading some files in order for the operating system to work. And the boot virus will place itself in that area. Macro viruses, which is a virus is written as a macro to execute malicious code. Most of the viruses are macro viruses. Polymorphic viruses, which is a virus type that constantly morph or changes its footprint to full viruses detection software. If we talk about software that detects viruses, there's two mainly types. One will work on a signature of the virus and one of the profile of the virus. So a profile, that means a company will find the virus, will identify how the code will work, what's the name of it, what's the code in it, and it will update the definition of it. And when you have an anti-malware and you update your anti-malware, you will get that file, which is the definition file. And now you know that your operating system will know that this is a virus. But the other one, which technically the anti-malware will work on opening the code and see what is executing. If it's executing maliciously some information, then we will stop over here and say this is a virus. We have two type. One is on information. Now, need to have information to be updated. Now, this type of polymorphic virus going to change itself, and by changing itself will be harder to detect for an not updated information or not well programmed anti-malwares. Worms, similar to virus, that has the ability to self-replicate while working its way through the network. It do not require an input from the user. Rootkit are purposely designed to hide in your operating system by hiding fragment of the executable and deleting detectable fragment after it's execute on the intended target, and installing itself part of the system registry or a master boot record. That's why it's worse. Sometimes you need to format the entire operating system, delete the operating system, and have a new one, because it's really destroying the way that it can be executed or be find out. What we have more, operating system defense tactics. One of the first steps to hardening your operating system is to develop a multi-layer approach to your security strategy. We call it a defense in depth. Adding a multi-layer will help to detect if the first layer fails to detect the virus. The second layer can find it and then can protect it. So we call it security in depth. Make it complicated as much we can, but simple at the same exact time. How it work, I don't know. Complicated at the same time and simple as possible. You close the gap and strengthen your walls by finding services you don't use, shutting them down, and make them unavailable to an attacker. For example, you have a server. This server is enabled on the network, and you don't use this server for file transfer. If you don't use this server for file transfer, why you enable on it FTP? Why you have port number 21 open? That's the question that you need to ask. If you don't use it, close it. Why you have this in your mind? Why you put a vulnerability in your system? Just close it, because there's a possibility you don't know that a virus can be installed and can use that port to send and receive information. Mac operating system 10 Snow Leopard, which is there are many industry applications that can help an organization harden its operating system. One of them is the NIST. For example, put out an update operating system hardening checklist that can help you with this task. And the following URLs identify the organization that produce a wealth of information. We have the, starting with DISA, Defense Information System Agency, National Institute of Standard and Technology, NIST, and this is a government agency, by the way. And then we have the NSA, which is the National Security Agency, and is also a government agency. And there's one more, which is CISA, and this is a new agency, belongs to the human Homeland Security. Their website is cisa.gov, and it's cybersecurity information infrastructure, something like that. I forget. So cisa.gov. So the baseline: never use the administrator account to conduct daily tasks, such as surfing the web or checking your email. Never ever use administrator account. Create an administrator account, complete your setup, create a username, and use that username. So whenever you want to set up something or add an application, you need to switch the user to the administrator or gain the administrating information. Then you will go and install the one that you want to do. But don't use the administrator account to conduct daily tasks. Anyone with malicious intent can easily defeat all other password mechanism unless you have the framework password set. Okay. In system preferences settings on a Mac, you can also disable automatic login by setting the automatic login to be off position. It's also important to disable the sharing for guest account by unchecking the selection. So don't use a guest account. Mac operating system 10 also include two firewalls that include a packet filtering and application version. The packet filtering firewall requires some expertise through infrastructure that can readily be found on Apple website and Mac operating system and security configuration guide. And we're talking about Mac, but technically can apply if you have can apply on another operating system. The built-in camera and microphone should be disabled if needed because these hardware devices can be compromised. In Linux, we can figure the usual practice that you should start with when implementing Linux-based system, but create users or user accounts using a strong password. Don't use an easy password. Just as when you are using a Mac, do not work off administrator or a root account to conduct non-administrative tasks. Review your system logs and store them on a server. Encrypt log information and encrypt critical data infrastructure to avoid interception. Also, you should set up your BIOS to disable booting from external device and set a password to the bootloader. Because Linux works on an open source code, you should be very careful when downloading application on an unknown origin. Turn off unnecessary service if you need. Linux also has several encryption options available for encrypting any portion of the media or file system. For file encryption, you can use the GPG, GNU PG, which is a single file encryption tool. I'm reading out of your chapter, then we will go to your project. So just bear with me. What's his name?
Her name's Peachtini.
It's her. Okay. What's the name?
Peachtini.
Peachtini. Okay. Mine is called Boney because when I got it was like really tiny and bony. Now it's like so big. It's fat. No more bony. It was like really skinny. Okay. Windows 7 comes with a bit locker. Now again, Windows 7, some of them, not all of them, professional, I think, enterprise have that. BitLocker, which is available with the enterprise and the ultimate edition, and enable the user to encrypt the entire hard drive. Don't. UAC, which is user account control, notify the user of any changes or attempts to the changes to the system by an application. Internet Explorer now comes with features called Smart Screen that checks for all sites. Don't use it. You visit against a database to ensure that you are visiting a safe, legitimate site. This filter also protects your system against cross-site encrypting. Don't trust it. They are lying. Don't take my words. Okay, auditing, monitoring and auditing changes that occur in information system are crucial to effectively manage security in an organization infrastructure. Inside Windows also there's a tool that can, if you go to computer management, there's a log event where you can see what happens and you can view the events that's happened, and that will give you an idea about what happened just on your operating system. What we have more, auditing requires that a written policy be established that determine the tactics on how and which event will be archived. Auditing and monitoring help you to identify baseline for resources usage. Now, if there's no policies in written, it will not be applied. It's hard to apply something that you don't have it in written. When you have it in written, you need to have a system that can apply it. Backup and redundancy, one of the best things that you do to yourself is to back up your operating system on an on technically, I don't want to say monthly or daily, but at least you need to back it up by now and then. If you're using a normal computer, if you're an organization, you must back up daily. Data backups and redundancy procedures are critical piece of operating system environment. Server redundancy can be achieved by maintaining a redundant server that can be mirrored and hosted many miles away. An organization can have an entire site complete with server data and power many hardner of away hundred of miles away from or containing a way that stand by ready to take over operating in event of such a disaster. There's something called a disaster recovery policy, and disaster recovery policy. There's one more. Business continuity policy and disaster policy. A disaster recovery policy, this is what they are talking about, that you have a system that's ready to take out away from your location. Reason why, in case of you hit by a hurricane, your system should be already in another place. This is a redundancy. That means these two servers having the same exact data at the same exact time. This is a redundancy. There are three types of data backups. Let's talk about two more. We have internal backup and external backup, and then we have these things, which is data backups. We have full backup, which you back up the entire data, copy of the entire drive. Differential backup, you are backing up only the data that has been altered or changed during a given period. So let me say we took the backup on Sunday night. Monday we will take whatever change. Tuesday will whatever change until we reach Sunday. Then we run a backup. That's a differential backup. Incremental backup, different story. You have a full backup on Monday, for example, or on Sunday. Monday will take a percentage. Sunday will take a percent. Tuesday will take percentage. Wednesday will take a percentage until you reach Sunday. Will reach 100% again, and that's an incremental backup. There's something called redundant array of independent drives, RAID. RAID 0 does not provide fault tolerance, but simply improve the read and write performance by using disk stripping, which separate blocks of data across disk array. RAID 1, which uses a disk mirror to provide fault tolerance. Disk mirroring, which is used for several drives connected to the same RAID disk controller, which sends a duplicate data to the other disks in the RAID to create a mirror of the data. RAID 5, which is used multiple drive, but stores error checking data, known as party data, and all drivers in the array instead of just one, providing an additional layer of protection. And RAID 10 or RAID 01, which is use mirror and stripping at the same exact time, and that's kind of a higher level, which is a higher degree of read and write performance than the RAID levels that we just mentioned. Remote access security or services. Remote access services are deployed when using servers on software to allow remote workers the same access used by an employee working at a physical organization, faculty or facility. Remote access policies should be built to provide consistency, should be part of new user training requirement for network use, and should managed by the information security group within the organization. I think there's two type of remote access. One is remote desktop remote access or remote desktop connection. Remote desktop connection, and the other one will notify the user. One will not notify the user, but you need to have the user information. Virtualization, which is going to allow the system administrator the opportunity to consolidate systems resources using a logical view of the system resources rather than physical. So rather than having a PC with 4 or 20 gigabyte, you can divide this PC 10 to be on one operating system and 10 to be on the other operating system. That's virtualization. The instances of an operating system operating on a virtual machine are managed by what is called hyperversion. The hyperversion control the flow of data that include instruction between the guest operating system and the physical hardware. And that's the summary of the question of the chapter. Questions? No questions. Let's put this on this side. No questions? Okay. Let's talk about your homework. Project 4. I have like a bunch of people. Okay, come on, faster. Yeah, internet connection is unstable. That's not the thing. Project 4. Hashes and signature. Now, the idea of having, when you download something, you need to make sure that this file has a legit signature, that it's coming. If it's coming from this website, you need to make sure that it's really coming from this website and is not being altered in the way. So technically, what it asks you is to go to this website and you download that filealizer and the latest one. And technically, I've already downloaded. So let me go to bring it up. Download yesterday. Okay, that's the file. I don't know why my internet is so slow, but so this is the application that they ask you to download. You need to download it from here. So you'll download it from here. Then
You're cutting out kind of hard.
Yeah, I have bad internet. I really have bad internet now, and I cannot disconnect. Okay, I'm going to go slowly. Download filealizer. Go and download the latest one. Now we need to verify the hash, the MD5 and the SH1 hashes. How we can do that? You need to put this on a desktop. Let me put this on the side. So this is filealizer. You can see it over here. Yeah, start stopping. Then we have to go to the properties. After you install, okay, you need to install that file. After you install it, go to it and right click and you will find Analyze with Filealizer and click over here and we'll open this window, and they want you to look on the MD5 and the SH1, and you need to have a look on the 4-letter of MD5. You can see D670, right? So let me stop over here. That's one of the things that we need to have a look at before we proceed. Making a copy, they want you to right click on it and drag it and release it and say copy here. And now you have a copy of this application, and you can right click the same thing and Analyze with Filealizer, and you can see is the same hash have not been changed. Now, after we check that, we are going to install something called HXD. After we install it, we are going to go to the application, which we can call it from here. And we say open. And we will go to the desktop. Come on. Desktop. Locate the copy, which is this one. Open it. And now we have the hexadecimal code of the application. Do you see where, say over here, this program must run under Win32. We are going to change it into 64. So just put the point without using a backspace or something and just put 64. Then you are going to save it and exit out. Now we are going to check if this file have the same exact hash. So we will go right click, analyze with file analyzer, and we will see that it does not have the same hash. This is okay. This is the old one, the D670, and this is the one that I'm talking about that we modified. It is not the same. In fact, if you go into the properties and you go to compatibility, I think. No, digital signature. Digital signature, you go to the safer networking, you open that details, and you can see where it says digital structure information. This digital signature is not valid because it was modified by you. And you come here, you go to properties, digital signature, and go to the details over here, and you can say this is okay. And you can see the difference between the one that you modified and the one that you did not modify. So technically, whenever you install an application, the first thing that you come here and make sure that is a digital, the signature is valid. And that's it. You take the screenshot and you upload them. You need to have at least 3 images. Questions?
Do these programs work on Mac, or do I have to do them on Windows?
I think they have for Mac. Oh, you have Mac?
Yes.
Oh, no. Do you have Windows?
Yeah, I have a separate Windows computer.
Okay. You can use the Windows computer. If you don't have Windows and you have Linux, you can use Wine. Have you ever used Linux with Wine? It's nice. I don't know if Mac have Wine, because you can use Wine and you can run an .exe applications. But I don't know Mac if it has it. But Linux, I'm pretty sure, because I use Linux a lot, and we have something called Wine. But I don't know if it has for Mac.
Okay.
Questions? No questions? Okay. Then, number 1, take care. You have an exam. Good luck. Make sure that you complete the exam and for a project as well. Make sure that you already did cover all of the chapter project discussion. It's just like for me to make sure that you are active and up to date with the work. Next week, we will talk about Module 2. You will have an announcement from me by next week about Module 2, what we are going to do, what's our activity. Until then, see you next week.
Thank you very much.
Thank you.
Bye.